Okay? You already know this one, that the mean of the sample proportions was the population proportion. So let's read it. It says the Gallup organization surveyed people in over 100 countries in December of 2010. They asked people about global warming. Global warming is the gradual increase in the Earth's average temperature. Gallup asked people if they think global warming is a serious threat to them or their family. Gallup found that 42% of adults in its sample believe that global warming is a serious threat to themselves and their family. Imagine, now this is the part we're going to imagine, 42% is the population proportion of all adults all over the world that think global warming is a threat. 42%. We don't know this, but we're pretending. Everybody on board? We found a random sample. So here's a sample of 200 adults just off to the side, and we're bringing it in. Okay? We've got 200 adults in which only 34% believe global warming is a problem. Is that a sample proportion or a population proportion? It's a sample proportion. Got it? Which one of these is P and which one is P hat?
42 is P, 34 is P hat.
42 is P, 34 is P hat. Okay. Now, 34% in the sample believe global warming is a serious threat. Is that sample proportion unusual? That's all you have to answer. Is the 34% unusual? Make a display, meaning they want you to draw a graph. Okay? Make a display and present a statistical argument to explain how you arrived at your answer.
So do we make that like the bell shape? I think.
No, we don't even have enough for the formula.
Yeah.
We need to deviate this some way.
Some way.
So do we need like big this?
We need the average to deviate it. So what is the average of 200 adults? Can't we do that
Well,
thing?
isn't it the same?
Well, no, the first.
Remember, .18 was the same as something. Was that the popular? No.
The first one was the 42% is 100 countries, and then the second one is 200 people.
So we created a number.
Is this kind of dumb if like we're trying to find the mean right here or
Yeah,
the
we're trying to
mu?
find the mean.
Okay, but can we just divide by the p hat on both sides?
I'm going to write it up easily.
Do algebra again. We don't have an average or the mean or whatever.
What's the
Okay, so we have mu p hat equals p.
Yeah.
So then you divide by whatever p hat is on both sides. And what was the p hat? The 34%? I don't know if I'm doing that.
Yeah, it's 34.
So 0.34 and then just the m's right there, 0.34, and then what's the population is
42.
42, and then take the this pencil 34, and then that'll get the average. I don't know.
What is the mean? The mean is 1.24. The sigma is what? We need the standard deviation. 1.
That's if we're getting a z-score. I mean, but it's the same thing, no?
Yeah, because we're missing
It's the same answer. A z-score is the
So
same
what's our
thing.
lower?
It's gonna be the 0.42.
And our upper?
It's gonna be 999.
That comes up to 0.79.
So 79%. So wait, what is this even?
So is the proportion unusual?
Everybody's on board on something. I'm sorry to interrupt, and that's probably really rude. Forgive me. This is not the mean times anything. It's the mean of something.
Probability and
Okay, so you're doing probabilities.
so we need to do the inverse.
No, I don't know what you're trying to compute.
We're trying to answer the same question.
I don't think it's unusual.
We're trying because
What is it? What do you think? What's your understanding of what makes something unusual?
Okay, the mean is
something has 2
0.42.
deviations from
Yeah, and the 30.
sample size
Is N, right?
is N.
Which is
Yeah,
0.34.
No, it's 200.
So it is
The sample size is the number of people in the survey.
So 200.
So you guys were right. I'm sorry.
The sample size is the number of people in
So
the
it's
survey.
1.24, because we did 2 of them.
Yeah.
No, it's not either of those.
What's 0.0348?
That's the standard deviation.
Yeah. With that,
So sigma is the deviation thing, right? So that's 0.3. Can we just round up to 3.5 for the deviation?
we don't need to round it. We already computed it.
So
Can't be
the
90%.
question is if it is unusual.
Is the standard deviation usual or the percentage?
Yeah, it's unusual because if 34%, 42 is the mean, right? And then 0.34, the deviation is 3.5.
It's 0.0348.
Yeah, which would be.
Subtract that from 0.42.
Yeah.
Yeah, but you don't need to subtract it. 3.4, that would be more.
What would that be if we
It'd
subtracted
be like 6.8.
Smarty? Come out right.
41.96. So that's one thing, right? 41.96 is one thing. Then subtract it again. 0.0348. 41, that's another one. So 34 is unusual.
Yeah, it is unusual. It's farther.
That's what I'm saying. It's 0.8 away, and then
So-
this
Here's
is.
yes.
It is way past. It's 2
is.
deviations.
So we said yes.
Okay,
You're calling it unusual now?
yes. Because we just subtracted that standard deviation, and once we passed the 2 deviations, it was, we still didn't get to the.
All right, ladies and gentlemen, we've got
Oh,
to
they're
lock
waiting
this. So we're adding 0.035 here, the standard deviation.
To 0.42.
Right, now we're going to subtract it from 0.420. And what do you get for one standard deviation below? And what are we trying to answer? Okay, so here we have our intervals, correct? So 0.34 is going to be down here. Unusual?
Yes.
That's more than 2 standard deviations below. So, Z. Now we used to do x minus mu over sigma, right? But it's not really x. Is it?
No.
It's, what was the 34? What are we calling that? P hat, right. So let's change the x to a p hat. And we should use the right mean. The mean of p hat values is mu sub p hat. You see? And the standard deviation of p hat values is sigma sub p hat.